Hey guys, I thought I would just film this short video on question 18 from assignment 6. This question has 4 parts, and I'm just going to kind of walk you through each part and do them with you. We'll go over them together. So, part of the reason that I chose to do this question is that it did trip me up a little when I was first doing the assignment, and I thought it would be a good question to make a video on. Once you get the hang of it, it's actually pretty easy. And I'm just going to show you how this is done. So the first thing we can see is that we're given information about a run, and we're given the mean and the standard deviation. So these are sort of the first 2 data points we can pull out. And we can fill them in right over here, so we can reference these in our formulas easily. So our mean is 64, and our standard deviation is 15. And I've just kind of got these set up to autocomplete. Next, we're asked what percentage of finishers, or approximately what percentage of finishers, had times between 45 and 75 minutes? So this is kind of exactly like some of the examples the teacher did in class. We're going to find the distribution, or what percentage of people had that runtime, and we're going to subtract the smaller number from the larger number. And to do that, we're going to use these formulas. And the larger and smaller here don't mean anything. Those are just sort of to set it up so that it looks like it's a normal arithmetic equation. So our numbers under consideration are going to be 75 and 45. And the very first thing we're going to do is we're going to use this formula. We're going to use norm.dist because this isn't a standard curve. This is a different distribution. And we can double click to complete this formula. So x will be our number under consideration, in this case 75. The mean is 64, the standard deviation 15, and in this class we always use cumulative, so we're going to press true and close our bracket. Next, we need the normal distribution of the smaller number. So we're going to press equals, we're going to start typing again, norm.dist, and we're going to go through exactly the same steps for the smaller number, the mean, the standard deviation, and of course the true flag. So now, and this is going to be exactly just like normal arithmetic, we're just going to subtract the smaller number from the largest number. So we're going to press equals, the larger number minus the smaller number, and we're going to see that we get 66.57%. And this number here is this cell exactly. We don't change anything. We just format it as a percentage. And we can see that we got the right answer here. Part B is actually much easier than part 1. All they're asking is what percentage of finishers had times less than 80 minutes. So in this case, x, or our number under consideration, is 80. And we can do this all in one step with norm.dist. So we're just going to select the formula. Oops, we're not going to select that cell because 80 is going to be our number under consideration. Then our mean of 64, our standard deviation of 15, and our true flag. And in one step, we'll get the right answer. So 85% of people, well, almost 86% of people finished with less than 80 minutes. And we can see we got the right answer here. So this is sort of the part that confused me. Obtain and interpret the 40th percentile for the finishing times. And what that is asking is 40% of the finishing times are under what number? So in a sense, we're being given the percentage, and we're being asked to find what number is under consideration. So instead of being given our x, we're being given our norm.dist number. And in this case, that's 40%, because that's what the 40th percentile means. So we're just going to enter 0.4 here, and we're going to use a slightly different function, norm.inv. And this will return to us, if we have the percentage, the mean, and the standard deviation, this will return to us what the number under consideration would be. Basically, how many minutes below, so 40% of the finishing times will be below this number of minutes. That's what this is going to give us. So we're going to type norm.in. We're asked for the probability, in this case 40%, and remember not to type 40% but to format it as a decimal, because Excel will always want these numbers formatted as decimals. Then the mean, the standard deviation, and we don't have a true or false flag here, we can just close our brackets. So we'll see that 40% of the racers finished in that's basically 60 minutes. And here we're just asked for the interpretation, and that's exactly what it says. And then this sort of confused me too, because I had actually never seen the word decile before, and I had to look up what it meant. And all that it's asking is asking the exact same thing as in question C, except for 70% instead of 40. So in this case, our percentage is going to be 0.7, and we're going to use the same formula, norm.inv, with our probability, our mean, and our standard deviation. So this is actually going to not return the right, well, it is going to return the right answer, but when I originally did this, I did it using a different method, and I got a different answer, a close answer, but not the correct one as far as Excel is concerned. And this is what the teacher said when she meant that Pearson is pretty good about rounding. This question could tell I used a different method, but still arrived at what it considered the right answer. And Excel gave me a much more accurate answer using norm.inv, which is also correct. And I think that if you entered this, I actually can't go back and test it, but I think that if you entered this, it would also mark it correct. So finally, there's sort of one more way we can arrive at this number, or a number close to this. What we're going to do is we're going to enter any number for our number under consideration. It doesn't really matter, and we're going to use norm.dist. With our number under consideration, our mean, our standard deviation, and of course our true flag. So next, we're going to, so what this is telling us is that this number here is 10.26%, and we want this number to be 70%. So we can select this cell and we can do a what if analysis, and we can goal seek. We can try and find the goal we want. So we're going to change the value in this cell to the value 0.7 or 70%. That's the value we want this cell to have. And since it's linked to this cell, we're going to change this cell. That's the cell we want to change the value here. And we can press OK. And Excel will get as close as it can. And in this case, we'll get a third different answer. We'll get 71.85, which is again actually a lot closer than the norm.inv got us. And it's closer than this method got us, but Pearson understands what you're doing, and it does understand rounding very well. So it would actually accept pretty much any one of these answers. So that's it. That's everything for question 18.